Hello and welcome to this video for Breakthrough. This is the skeleton code for the AQA Computer Science Paper 1 in 2022. Before you go any further watching this video, a few things you need to do. Number one, make sure that you have read all of the preliminary material carefully and that you understand it. Run the program. Make sure that you played the game a few times. Make sure that you are fully understanding of all of the rules of the game. Step through the code, use your IDE. So I'll be going through this in C# where I usually use Visual Studio, and there are lots of facilities within that to be able to step through code one line at a time, to use breakpoints where necessary. So for instance, if I'm looking at a bit of code where there's an iteration and maybe it keeps on looping several times, I can set a breakpoint at the end of that loop and then continue stepping through line by line after that. You can also use your IDE to inspect the values that are being stored in the different variables and data structures whilst the code is running to help you with your understanding. And finally, make sure you understand the different classes and the relationships between those classes. What we're looking at here is the UML class diagram for the program. This has been generated automatically by Visual Studio. And what we'll be doing is looking at each of these classes and methods in detail shortly. When the program starts executing, it will, as we'd expect in the program class here, it will start with the main method. And one of the things it does is it creates a new object which is based on this class here called Breakthrough. You can see the attributes. These are called fields in this automatically generated UML diagram here. So these are the attributes and these are the methods here. When we look at the data types of some of these fields, we'll see that it's actually declaring a number of objects which are based on this card collection class over here. So these are some of the different objects created within here, for instance the hand, the deck and a few others that are based on this class here. So we can already see that there's some association being used in here where the Breakthrough class contains some objects based on this card collection class. We're looking a little bit closer now at the card class. You can see that the card class has these two subclasses, difficulty card and tool card. So again, looking at some of the features of the program, we've got inheritance here. And if we look at the get description method in the card class, we can see that this is defined again in the two subclasses. So we've got polymorphism there where we are overriding methods here, and we've also got examples of where we're taking a parent class and then we're extending those by adding additional attributes and methods. Looking in a bit more detail, we've got card collection here. One of the attributes in here, we've got this one called cards, and when this actually gets instantiated as a list of objects, which we'll see later, it's actually a list of card objects. So card collection contains a list of these card objects. We've also got in our lock class here, which contains challenges. In fact, it'll be a list of challenges, and this is based on the challenge class. So again, we've got association where we've got one object containing another. So we'll now start looking at the code. My intention as we go through this is to look at it in sequence, looking at the different methods roughly in the order that we'd expect them to be called when we're actually running and executing the program. I suppose one of the things I should point out is this might mean that I don't go down every single branch of the code. So starting with the main method here. This is in the program class, as we can see. As we'd expect, this is where our program starts executing, and the first thing it does is, well, we've got instantiation, haven't we? We've got a class called Breakthrough. It's making an object based on that class, and so for it to do that, it calls the constructor method for Breakthrough. So shall we take a look at that constructor method? So this is a constructor method for the Breakthrough class. So the breakthrough class itself contains a number of attributes. There's an object for generating random numbers. This is based on the random class. And then we've got these 4 card collections. When we looked at your UML class diagram earlier, you may remember that the card collection contains a list of cards. So it's basically making 4 stacks of cards: deck, hand, sequence, and the discard pile, and we'll start looking at each of these in more detail shortly. It's also got a list of locks which are going to be loaded in from the data file, and there's the current lock, which is the lock that we're currently trying to solve. And what else can we see? We can see that it's going to create these 4 objects here: deck, hand, sequence, and discard. And for it to do that, it needs to call the constructor method on card collection, passing each of these as a parameter each time it does that. So shall we have a look at what happens when it calls this? So we're just looking at part of the card collection class here. We're not looking at the whole thing yet. We see that each of these card collection objects will have its own list of cards here. So when it makes a deck, for instance, the deck will have a list of cards. When it makes a sequence pile, that has a list of cards, and so on. This is the constructor method here. Constructor method, just remind yourself, the constructor method will always have the same name as the class itself, and we saw that it was passing in either deck or hand and so on, sequence, discard, which goes into this temporary variable n, which then gets assigned into the name attribute. Just looking briefly at the card class, we can see each card in the list of cards that's being created will have its own card number and its own score. But we've also got this. This is a static attribute, static int next card number. What this means is that each card, rather than having its own value for this, as each card would have its own card number and its own value for card score, this is shared. So every single card object can see this, but it only has one version of it, only one value that they all share. So having now created the 4 different collections of cards, it now sets the score to 0, so that's initializing it, and then calls the load locks method. So this is the method that's being called, load locks. It declares some variables for storing the file name, so default file name there, and this is a single line of text that will be read from the file. So this is really a temporary variable to store a single line that's going to be read from the file. It creates a list of strings here called challenges, more on this in a sec, and it creates a new list of locks. So we've got our lock class that we looked at when we looked at the UML diagram, and it's making a list of those called locks. When we looked at the lock class, I think mentioned that it actually contained a list of challenges. So this is saying within this list of locks, each single lock will contain this list of challenges, and this is based on the challenge class. The challenge class itself contains a list of conditions and also this Boolean variable here that records whether or not that challenge has been met. So what we've got is a list of locks. Each lock contains a list of challenges, and each challenge consists of a list of strings. So having set up the challenges and the locks, it now tries to process the locks file. Notice we've got some exception handling here, try catch. The reason for this is if there's any problem when we open the data file, it's going to jump down here to the catch part of our code and output this message, file not loaded. Maybe that's something you want to think about. Why might we have an error when we're loading data from the file, such as if, for instance, the file doesn't exist or it's not accessible for some other reason? So what does this code do? Well, firstly, it opens the file and then it reads in a single line from the file. It then goes into this loop. So what it's doing, just skipping over some of this for a moment, it says while line from file does not equal null. Null is a character that it will encounter right at the end of the data file. So if it hasn't reached the end of the file yet, it does some processing on the one it's just read in. It's already read in the first line, and then once it's done that, it reads in the next line from the file and goes back up to the top. So it opens a file, it reads a line in from the file, and it will do these one line at a time, and then it splits the line of data that it's just read in on the semicolon. So it takes that line, splits using the semicolon as a delimiter, and then converts that into a list, which it then stores in challenges. Okay, so what it's got now is a list of strings. It's taken the line that it would read in from the file, split it where it's found the semicolons, and then put that into challenges. Each string that it's put into there will describe a separate challenge. Okay, so this would be our first challenge, and then this would be our second challenge. It then creates a new lock object called lock from file. So this is calling the constructor method to make a new lock, and then it will process the challenges list. So that challenges list that we got earlier, this is saying go through each one at a time. I'm using the for each loop. Each time it takes a new one from that list, it stores it in the temporary variable C. It does something similar to what we just saw here, in that it splits that string, and it splits it this time on the comma. So whereas before it split this into two elements separated on the single semicolon that we've got there if it was reading this line in, now it's just processing this first one, and it's taken that string and it's separating it on the comma. So you can see we've got 1, 2, 3 different items. So when it splits those, it puts those into this conditions list of strings. It then takes that list of strings representing the conditions and passes it as a parameter into this method. So it's taking the lock that it's just made, and it calls the add challenge method, passing that list of conditions as a parameter. So looking at an example, here we go, looking at our file that we just read in the first line from, it reads the first line in, so this is the entire line here. It then splits this into two challenges, so this is on the semicolon, which is using it as a separator. Hopefully you can see these are both highlighted with an orange circle around them. It then separates this first challenge into the three separate conditions. Each of these has now got an outline in red, and it separates them on the comma delimiter, and then these conditions are passed to add challenge in the lock from file object here. So when it created a new lock called lock from file, we can see that that new object itself contains a list of challenge objects called challenges. The lock class contains a number of virtual methods. As you can see, this is virtual. That means we could override it. So it might be reasonable to think that this might be something that you're asked to do on an exam, to create, for instance, a subclass of lock, which is now able to override these methods that are currently defined as virtual. That's something to think about before the exam. When this add challenge method is called on lock from file, it takes a list of conditions as our parameter here, which it now is calling condition. It creates a new temporary challenge that it simply calls C, and then it calls the set condition method on that new challenge, passing this list of conditions here, this list as a parameter. This is the value that was passed in earlier, and then it adds C to the list of challenges. Let's have a look at this set condition method. So we can see that when the challenge, the one called C, was created, it contains a list of strings called condition. The list of conditions that's just been passed in as a parameter here has now been assigned to that attribute. So after the conditions were added to the challenge C, then the challenge itself is added to the list of challenges. And just going back to load locks, we can see that once all the conditions have been added to lock from file challenge, this is what's happening in the for each loop here, then lock from file itself is added to the locks list. It then reads in the next line from the file and it does the whole process again until the whole file has been processed. So we've now set up our cards, our card collections. We've loaded our locks from the file, which is now completed running through the breakthrough constructor method. So we return here. We've just executed the first line. So now we'll call the play game method. Looking at this, you can see it's quite a sizable bit of code. So we'll look at this step by step. One of the first things it does is it looks at locks.count. If you recall, locks is the list of locks that was populated by reading in the data from the locks.txt file. So it's checking here that it was able to read the data in earlier. If not, then the game can't progress any further. It then sets game over to false and it creates a new lock called current lock, then calls setup game. So setup game asks the user if they want to load a game from the save game file or if they want to play a new game. What we'll do is, first of all, we'll look at what happens if they choose to load a game, in which case it calls the load game method, which we can see it must be returning a Boolean value, a true or false. This is basically saying if it's false, then it's game over. That means if it hasn't returned a value of true. So if it returns false, then it sets game over to true. So what we'll do is we'll look further at this method. And we can see it's been passed the parameter. This was the file name game1.txt going into this variable here. It then opens a stream reader, it opens the file itself and it reads it in one line at a time. You see it's reading in these various lines from the file, and as the lines are read in, it has to process them. So this is the file, the contents of the file that are read in, and we can see that the first value 8 here, it reads that in and it reads it in and stores it after converting it into an integer into the variable or the attribute score. It then reads in the next 2 lines from the file, that's these 2 here, and then passes those as parameters to setup lock. So setup lock has been passed these 2 lines from the file here as parameters, and you can see that it splits the line using the semicolon as a delimiter and then assigns the result to a list of strings here called split line. In this case, there are 4 separate strings because it splits where it finds a semicolon here, here, and here. So splitting either side of those should give us 4 strings. It then iterates, so we've got this for each loop here. So it iterates through each string in the list, splitting it using the comma as a delimiter. We saw this earlier in the load locks method, and this returns again a list here called conditions. So it returns a list of conditions, and then each of these conditions are then added to the current lock object using the add challenge method, which again we looked at that earlier. It then takes the second parameter and again splits using the semicolon as a delimiter. So this is now taking this list of n and y values, splitting on the semicolon, and it processes the list of y's and n's, this list of, and in turn it checks if they are y or n here, so it checks if it's a y. This indicates if each of the corresponding challenges that it's just processed from the previous line have been met. So if it's been set to y, then the set challenge method is called, passing the count and the value true. Count is the position in the list as it's going around, using count here as the index or the stepper in this for loop here. So it will pass that and the value true if the corresponding value here for that challenge is set to Y. And the set challenge met method simply calls set met for the challenge at the stated position in the list that was passed in, and also passes the true parameter. Maybe worth just pointing out again, this is another virtual method, so potentially it could be overridden if we had to make a subclass. The set met method itself is just a standard setter method. So with the current data file, there are 4 challenges, and challenges 0 and 2 are not met. So we're looking at these ones here, whilst challenges 1 and 3 have been met. So after processing the first 3 lines from the file, it then reads in the 4th line, the one that I've highlighted here, and it passes this to set up card collection from game file, and it passes the line itself and the hand card collection, and this is the one that was set up when the program started. You've probably guessed this line from the file represents the 5 cards that are currently held in the player's hand. So for the first time, at least, when this method's called, it's been past the 4th line of the file and it's been past the hand card collection. We'll see shortly how it then gets called again with the subsequent lines from the file and with the other 3 card collections. That's the sequence, the discard and the deck hands. It starts by creating a list of strings here called split line, and it checks the line passed in as a parameter isn't an empty string here, then splits the line again using the comma delimiter and puts the resulting list that it produces into this variable here, split line. We can see from the data passed in that there are 5 separate entries where they're each separated by those commas. We can see that some of these entries are 5 characters in length, such as the first one, so we've got P space A space 1, 5 altogether including the spaces. Some of them are 6 characters in length, such as the second entry there. The first if statement that we've got here checks the length and gets the card number, looking at either position 4 in the string, which would be the 5th characters, or looking at positions 4 and 5, taking 2 characters. Either way, they're then cast as integers and then stored in card number here. So depending on the length of that string, it will read 1 or 2 characters and store them in card number. As it iterates, so we've got this for each loop here, as it iterates through each of these strings, it checks if it's a difficulty card. So this is this line here. We'll come back to this later, as the player's hand can't actually contain a difficulty card, and at the moment we're looking at how it processes the hand. So it goes down the else branch here instead to create a new tool card, which is a subclass of card. If you recall, there's the card, and then we can have either a tool card or a difficulty card as subclasses, and it adds that card to card call, which is the parameter that was passed in. In this case, we're looking at the hand, so it's basically saying, okay, I need to add that to the current card here that we've just processed to the hand card collection. So when it looks to see if the first 3 characters of the string are diff, such as we've got here, well, this is something we can see on the last line of the file, which is we're just briefly looking at here. This is previous we were looking at the hand collection. This is actually for the deck card collection, and so where it finds a diff where this is the case, it actually creates a new difficulty card here. Okay. And it passes the previously obtained card number. In this example, it would be the 34 here as a parameter, and passes that in to the constructor method. So this is the method that's being called the constructor method for difficulty card. As we can see, difficulty card is a subclass of card, and you can see here that there are actually two constructor methods, i.e. it's overloaded. In this case, we've called it whilst passing in a single parameter, the card number, so it's this one that's being called. And it simply sets the card type to diff and card number to the card number that was passed in as a parameter. So just returning to looking at what would happen when it processes this line from the file, which it's just created the difficulty card, it would now add that card to card collection, calling the add card method. So this is the add card method. So in either case, where it gets called either here or here, it simply passes the card in and then just adds it to the list of cards. So we took a bit of a detour there looking at what happens if it was processing a difficulty card. Obviously, we said for the hand you wouldn't get a difficulty card. So for any other type of card, i.e. where the first three characters are not diff, it's going to go down the else branch here. So it creates a new tool card here, which it calls current card, calling the constructor method. And you can see it's passing these values here. These are the values at position 0 and 2, as well as the card number, and that's for the highlighted card that we're looking at here. This would be the P and the 1 that are being passed in as parameters. So again, we can see we've got two constructor methods here for the tool card. So similar to the difficulty card, it's a subclass of card, overloaded again. In this case, it's being passed, well, if we pass in the 3 parameters, it's going to call this one. If you pass it with the 2 parameters, it will call this one. In this case, I think we passed 3, so it's the second implementation, and it uses the parameters to set 3 of the card's attributes. So the P that it passed in is basically saying that the tool type is a pick. Once it's set these here, it then calls set score. So this is set score. It's within the tool card class. It's pretty straightforward to see what it does, isn't it? It just looks at the tool type, key, file or pick, and sets the appropriate score for that. So we can see that the for each loop that we're going around here, which is looking at split line, which if you recall was for each of these items here separated by the commas. So it's going to repeat in this case 5 times, and each time it goes around, it's going to take the data for that, create a card, and add that card to the collection. And just returning back then to load game, we can see that the final 4 lines of the code here are all processed in a similar way. It will read the line from the file, pass it to the subroutine, which then processes that line to extract the details for each individual card and adds the cards to each of the specific 4 card collections. At this point, the load game subroutine should return true and terminate, which is what we'd expect to find here. So it's processed the different lines of the 4 lines at the bottom here, taken the data, added it to the hand, the sequence, the discard, and the deck collections, and then returns true. You can see it's using exception handling. We've got try, catch here. That should catch any issues. So for instance, opening the file here, reading from the file, if there's a lock on the file or something like that, the file doesn't exist. In that case, we would get this message instead saying file not loaded, and it would return false instead. So just one final thing really before moving on. We've now seen how the file is loaded and processed, so we can see what the lines are. So on the first line here, we've got the score, then we've got the lock and the challenges and whether those challenges have been met. And then we've got 4 lines here. The third one is empty in the file. So those 4 lines there represent the hand, the sequence, so hand here, sequence there, discard, which is empty, and the deck, which is the longest one because it's got the biggest pile of cards on it when we load in the file there. So following stepping through the program, and we've just had a look at what happens if you chose option L to load a game, how it loads the game, and so on. If you choose not to do this, it goes down the else branch instead. So let's have a look at this. The first thing it does is it calls this method create standard deck. So this method here simply creates a series of cards where their values are hard-coded. So it makes a card, you see it's passing the two parameters this time, creates those cards and calls add card again to the deck. So add card, we can see here, it just gets passed in a card and adds it to that card collection. So it adds those cards to the deck. And that's it. It's pretty straightforward, really. You can look at this and see that it repeats 5 times, and you can see the cards that are being added. So this will iterate 5 times, and you can see it's adding a pick, an A, pick a B, and a C, and so on. And then 3 times it does the files and the keys. So you should be able to work out how many of each card are being added to the deck. Now the cards have been added to the deck, it needs to shuffle the deck, and it does this by calling the shuffle method. The shuffle method, I should just remind you, is in the card collection class. Deck is an object of card collection. So it creates a random number generator. So it's an object from they're based on the random class, and it iterates 10,000 times. So each time it iterates, it generates 2 random numbers here. This is to indicate positions of cards within the deck, and it then swaps those 2 cards around. So this is basically swapping those cards around. It uses a third temporary value to be able to swap them. This is something you might be familiar with when you've studied bubble sort algorithms. When you want to swap 2 values, you need a third one to be able to do that, so you don't overwrite the first one with the second one. So having shuffled the deck here, we can see it now iterates 5 times. Each time it calls move card, and it passes the deck, the hand, and the card number. So this is returning a card number of the first card in the deck. So that's its index there, and we can see get card numbers being called here. We're passing in 0, and so that calls get card number and returns the one for that particular index. So let's have a look at move card then. So we can see firstly move card, this is in the breakthrough class here. We can see it returns an integer value. It's been passed, in this case the deck and the hand as card collections, passed into the from collection and to collection variables. So we can see that what it's doing is it wants to move cards from the deck to the hand, i.e. it's dealing cards, moving them from the deck to the player's hand. It was also passed the first card number from the deck, so it checks the to and from to see if it's from hand and sequence. In this case it's not, so we'll focus on the else branch instead down here. In this case it creates a new card object, card to move here, and it does this by calling the remove card method on the from collection, i.e. the deck. So on the deck it's calling remove card, remove this card number, and place that object, what it returns here, into this card to move. So when it called remove card here, it's been passed the card number. In the case that we're looking at the moment, this is the first card in the deck. So we've got this while loop here. It iterates through each of the cards until it finds the card at that position, the one that it's been passed. It sets cards to get equal to the found card at that position. It removes the card from the deck, using remove at. Remove at is a standard list method that simply removes the element at the position that's passed to it, and then it returns cards to get as a return value. So having removed the card, and then the card itself is returned here into this card to move card object, it now checks that the card isn't null before adding that card into the to collection, i.e. the hand. And then it returns the score, which might have changed if the other branch had been executed. So returning back to setup game, this is now iterated 5 times. It's dealt the cards, so it's moved those 5 cards into the hand, and now it calls add difficulty cards to deck. So this is fairly simple. It just iterates 5 times. Each time it creates a new difficulty card object, so that's calling the constructor for difficulty card, and adds it to the deck. Just looking again briefly at difficulty card, we can see, as we said earlier, it's a subclass of card. It's got this overloaded method here where we can either call it with a parameter or no parameter. So in this case, we haven't passed it a parameter, so it's going to be using the first implementation here. This using the base keyword here means first it calls the instantiator from the base method, so it's calling the constructor from the base method, i.e. the card constructor method. So this is our base class, our parent class card, and it uses this static attribute here, next card number. It being static means that it's shared by all of the cards and their subclasses. There's only one version of this shared amongst all of the card objects, and that would include the tool cards and difficulty cards. The constructor that's here, the code here that's being used here, will take the card number that we've got here, next card number, and places that into card number. So this value here, it gets put into card number, and then it increments that next card number and initializes the score to 0. So returning back to setup game, it will now call the shuffle method. And just a quick reminder, this is the shuffle method. We looked at this earlier. It's in the card collection class. So returning finally to setup game again, we're on this line now. So the last thing it does is it calls get random lock, which we can see is returning a lock that's going to be stored in this current lock here. Let's have a look at get random lock. So here it is. It's in the breakthrough class. It generates a random number here. This random number has to be within the range of available locks, and then just returns the one that it finds at that position is the return value here. So that's the lock that's been returned. And so we're all done. We've looked at how the game is set up if you load the game from the data file, and then we've looked at if you choose to play a new game without loading it from the file. So we've run setup game. We now go into this while loop here, and this iterates whilst it's not game over. So lock solved is initialized here to false. This indicates that we haven't completed the current lock yet. And then we go into another while loop, and this one keeps iterating whilst the lock isn't solved and whilst it's not game over. So first thing it does is output the score, which was initialized to 0 right at the start. Just a reminder, this is where the score got initialized to 0. And then it calls get lock details method on the current lock object, and then whatever the returned from this is going to be output. So looking at get lock details, firstly we can see it's another virtual method, meaning we could override it like the other methods in the lock class. It's going to be returning a string, which we said is going to be output by the calling method. So it starts to build up this string here. We can see it returns lock details, and this is where lock details is declared. This syntax here, environment.newline, simply adds a new line character. It's roughly equivalent to, you may have used /n previously for a new line, so it's roughly equivalent to that. So the first line that it creates here is just a heading. It then iterates here, so it loops through each of the challenges in that list of challenges, and each time it goes through each one, it calls the getMet method, which we can see, you know, if it's saying if c.getMet, that's basically saying if that's returning true. So if it's true, it's going to do this, otherwise it's doing this. So getMet method, here we go, just a standard getter, or to use a proper term, an accessor method. So if getMet returns true, meaning that that particular challenge had been met, then it adds this text challenge met to the string, otherwise it adds not met to the string, appending it to the end, which will eventually become the return value of this call, which itself is being passed the result of gets condition here. So what we've got is building up a string that says challenge met or not met, followed by the result of convert condition to string, which is being passed this, and then appending that to the end. So let's have a look at what's happening here. So get condition itself is another fairly straightforward get method, which is returning a list of strings. That's the list of strings that makes up the conditions for the current challenge. Convert condition to string takes that list of strings representing the conditions and basically goes through them and formats them so that they are properly formatted so that they can be output. When we run the program and we choose to use the save data file, the first set of challenges to be processed will be these ones here that are highlighted. So one of the things that's useful to do as you're getting to know the code is in Visual Studio we can look at the contents of variables. So you should get used to, as I said at the start of the video, you know, setting breakpoints, pausing, using F11 to step through. But we can look at the contents of the variable C here. So following the code, we can see that the variable condition as string is initialized here as an empty string. This is going to be our return value later on. It then iterates through the items in C, our list of 3 strings, but not the last one. You see it's doing C.count -2, so it's not doing the last one at the moment. It takes the string at each position here and then it appends a comma, so it adds a comma to the end. So it takes the first one and then adds a comma, takes the next one and adds a comma. Without doing a comma for the last one, it doesn't do the last one. So it adds a comma after the first one and the second one, and then you can see it does the last one separately without putting another comma on the end, because obviously with a list you don't put a comma after the last item, and then it returns that string as its return value. So having got the details for each challenge within the lock and then added them to the string, it finally adds another new line character here and then returns that string as its return value. And so this is what actually gets returned and then displayed when we run the program and we're using the saved game file, and you can see how it's formatted the data that we were looking at earlier, placing a comma there and a comma there, but not a comma at the end, just a new line character, and we can see whether it said challenge met or challenge not met for each of those challenges. So we've output the score, we've called getLockDetails. We're now going to call this one getCardDisplay. We're going to call it twice. So first we're going to call it on the sequence card collection and then on the hand. So as you can see, this is a long subroutine, one of the longest ones in the program. So we're going to break this one down. So again, we've got our subroutine here that's returning a string. This time the string that it returns will be showing the cards that are in the current card collection. If you recall, as we're stepping through the code, we're looking at it being called first for sequence, and then it will be called again for the hand card collection. So it creates this string here, which it initializes simply by putting a new line character followed by the name attribute and a colon. It checks if there are any cards in the current card collection. If there are no cards, the count equals 0, then it returns card display, the string we made here, and appends to the end of that empty, a couple more new lines, and returns it, and that's it. That's the end of the function. However, if there are some cards in the hand, it adds a couple more new line characters, and it creates this string and creates this integer constant cards per line. So this is the number of cards that it expects to be able to display on each line, or the maximum number at least. If the number of cards in the collection is greater than 10, as we can see here, that's our constant being used, it will call create line of dashes, passing the value 10 as the parameter. Otherwise it passes the number of cards as a parameter. So here it is, this is create line of dashes. You can see this is a value that's just been passed in and it's returning a string. And all it does is create a string containing dashes, which is the number of dashes is 6 times the amount of the parameter that's been passed in. And this line of dashes that's just been returned, it then adds that to the end of this card display string. So let's move down and look at the second half of this method. So we've just moved down and we're looking at the bottom half of the same method now. Firstly, it creates a couple more variables and then it goes into this while loop. So within this loop here, so while not complete, you can see this variable here, complete, at some point it should get set to true, but while it's false, it keeps going round and it adds to this card display string, and it's adding a pipe character and the result of calling get card description on the card that's at the current position indicated by pos here, which got initialized to 0. So when it calls get description, this is the method itself, and all it's doing really is formatting the card number, an integer, and converting it to a string. If it's a single digit card number, i.e. it's less than 10, then it adds a space in front of it, so we've got the space followed by the card number. Otherwise, if it's more than 1 digit, so it's going to be a 2-digit card number, it just returns it as the string equivalent. So just picking up back here, we've just called this and it increments the position, so now that's going to be pointing at the next card. It uses the mod operator here to work out if the current card, indicated by its position there, divides exactly by cards per line, which has got the value 10. If so, it adds a line of dashes on the line below. You see it's adding a line of dashes there. If the position is the same as the number of cards in the collection, it will set complete to true. That means it's all done with this loop, and so otherwise the loop will continue until all the cards have been processed and their descriptions have been added to that card display string. Now before returning, we've got this line here, so it's checking if the number of cards doesn't divide exactly by cards per line, 10. So it can fill up a line of cards every time it's got 10, but there might be some left over, hence it's checking if it's got a remainder there. And so if it does, if you just look at that code there, it adds another pipe symbol, another new line character, and it checks then if there are more cards that can fit on one line here, and if so, creates a new line of dashes for the remaining cards that won't fill a full line. Otherwise, the previous line of dashes would remain as it is. And then finally, this line of dashes is added to the card display string again, and then that is our final return value. So we've looked at how getCardDisplay works, and you can see, as we said, it's going to get called first on the sequence and then on hand, and as we said earlier, that's returning a string, so that string will now be output and then the next string will be output. And this is what the console window looks like, or at least if we use the saved game file. We can see it's displayed the results of get card display after being called on the sequence and the hand card collections. We see those clearly there. Each time it's displayed the name attribute followed by the descriptions of each card in the collection, and it's separated each of those with those pipe characters, and it's put the appropriate number of dashes above and below. So it's done exactly what we expected it to do. Just so you can see the effect of what we were talking about earlier, where if there's more than 10 cards, or if there are fewer than 10 cards and it's not an exact number that divides by 10, we can see that this is further on in the game when we've added more cards to the card sequence. So just looking at this line here, so we've got the code that displays the first 10 cards, and then it displays the dashes between them, and then it displays the next 10 cards, the next 2 cards with the dashes below. So that's the code that we were just looking at, and we can see what that looks like in action. Continuing our code then, we've got this call to get choice here, and we can see that get choice returns a string value that gets stored in menu choice. And looking at get choice at the same time, we can see it gets the user's input, converts it to an uppercase version of whatever they've typed in, and then returns it. So I've just moved a little bit further down that same piece of code here. So we've got our menu choice, and now it's using a switch case statement to deal with the choice. Note that there's no validation here or in get choice to check if the user entered anything other than a D or a U. So if you've entered anything other than that, then there's no kind of case default or anything like that. So again, think about tasks in the exam, that might be a fairly easy thing for you to fix. So if they entered a D for discard inspect, it calls get card display again, but this time it does it on the discard card collection. So this would then show the contents of the discard pile of cards, just as we've seen it being used a couple of minutes ago. If the user chose U, that means use card. Then there's quite a bit more to do. This is the real kind of playing the game part of the code now, not just setting things up and working around the edges, as it were. So the first thing it does is we can see it's calling get card choice, which returns an integer. So let's have a look at that. Here it is. This subroutine gets the user to select one of the cards in their hand by selecting a number between 1 and 5. Notice that there's some basic validation here. So we've got this do while, and it's using int try parse here. Hopefully you're all familiar with try parse. Try parse returns a boolean with a value of true if it was able to convert it. So this is basically taking the choice here and trying to convert it into an integer. So when the user types in their choice, it gets saved in this string. It tries to convert the string into an integer. If it was successful, it returns true. If it wasn't, then it's going to return false, which means it goes back around this do while loop until the user has entered something that it was able to successfully convert into an integer. Notice it doesn't actually check the value itself, whether that's between 1 and 5. If you run the program and enter a value outside of that range, 1 and 5, then I think it's possible to cause a runtime error. Again, could be an easy fix, couldn't it? That's something that you might have to do on your exam. I suppose just worth pointing out as well that try parse, again, you should be familiar with the use of the ref and out keywords. So in this case, it means that the function will put the value itself when it's being converted into value, and it's using the out keyword there, which means you can now access value afterwards. So value is declared there, it's passed in as a parameter, but it's passing it by reference rather than by value, and then we can access the value that's stored in value. So having got the player's card number, we are now going to call get discard or play choice, which again we can see is returning a string. So this is another fairly simple method just to get the user's input, and it takes the input and converts it to uppercase. Again, no validation here. So now we move on to this if statement to see if they chose D for discard or P for play. Let's look at discard first. So it calls move card here. This is a subroutine that we looked at earlier for moving a card from one card collection to another. So in this case, it's moving from the hand pile to the discard pile. Let's just quickly remind ourselves of what it's doing. So this time when it's called, it's hand that's being used as the from collection, discard as the to collection, and the user's choice of card number. So it moves the card with that number from the hand pile to the discard pile. Next, it calls get card from deck, passing card choice, which is that number between 1 and 5, as a parameter. This is another fairly sizable chunk of code. It's used in a few places in the program. The first thing it does is that it checks that there's at least one card left in the deck. Remember, if there's no cards in the deck, then it's game over. It then looks at the description of the first card in the deck and checks if it's a difficulty card. Here's what the preliminary material says about difficulty cards. So if the card at the top of the deck is a difficulty card, I'm going to let you read the rest. You can pause the video and read that for yourselves. Well, I'm going to move on. So firstly, the difficulty card has to be removed from the deck and a message is then displayed. So that's removing the first card in the deck and says difficulty encountered. It then displays the player's hand again, so get card display called again, and that gets output, followed by some instructions to select a card number or D to discard 5 cards from the deck. I'm hoping you paused the video and just read what it said in the preliminary material, or at least you're familiar with it. So when you get a difficulty card, you either give up one of your key cards or you have to get rid of 5 cards from the deck. Here's an example. So this is when I've been playing the game and I've just played card 1 from my hand, which is the FA card there. So I've played a file, and then having drawn a difficulty card, you can see here it's difficulty encountered, it's removed the card from the hand and redisplayed the hand. So my FA there has now gone. It's redisplayed the hand, which now only contains 4 cards rather than the usual 5. So it gets the user to enter their card number or D to discard. It reads in the choice, and the current card here gets added to the discard pile. It then calls the process method on the current card. That's the card that we've just removed from the deck, which is a difficulty card. It passes the 4 card collections, we can see there as parameters. It passes the current lock, and it passes the user's choice, which should be one of the numbers from 1 to 5 or a D. And the card's choice, which was passed in as a parameter also. Okay, so card choice we got passed in, so we're going to pass that along. This was the original card number that the player chose to play. In this case, we just looked and I said I was playing card number 1, which was that FA card. So that's what this value here would represent. So here we are. This is the code for process. Now we can see that this is a virtual method and that there's no implementation. Here we go. Look, curly brackets with nothing in them. So we need to look at the subclass for the implementation that's actually going to be used. So in this case, we were looking at a difficulty card. So we need to look at the process method that's in the difficulty subclass rather than in the card subclass. So here we are. As you can see, we've got the keyword override here. So that's saying I want to override the one that was in the parent class. So this is overriding the one that was in the card class that had no implementation code within it. You might expect to find a process method in the tool card subclass as well, because remember we've got the card and then there's the two subclasses, the tool card and the difficulty card. But there isn't one in tool card, meaning that when this method is called, it will only actually do anything if it's a difficulty card. So what does it do? Well, firstly, it converts the choice parameter to an integer. Again, it's using int.tryParse. The choice is the number of the key card that the player is discarding, the one they're getting rid of. If it's successful, it then checks that it's in the range 1 to 5. So that's on this line here. Note that choice could be a number or it could be the letter D for discard. Okay, so it doesn't do this next bit here if it wasn't an integer value that was passed in. If it wasn't able to convert it into, if you'd given the letter D, for instance, it wouldn't be able to do this, so then it wouldn't bother checking if it was between 1 and 5, because presumably you've entered a D instead. So now it needs to convert the player's choice, the number of the key card in their hand that they're discarding, into an index. So it subtracts 1 to do that. Okay, now this is where things get a little bit strange, and there appears to be an error in the code. But let's have a look at what it's doing rather than what we think it should be doing. It seems to be checking if the key card to be discarded comes after the original card that we've played. This seems to be so that the card number that the user's entered can be adjusted to account for the one that's already been removed. So its index would have to shuffle down and shuffle down again. However, because the card has already been discarded, the cards after it have been shuffled down and a position, so they've shuffled down one position already, and the new hand now only contains 4 cards, and it's displayed those 4 cards already, as we've seen. You can see we've played a card and it's already been removed from the hand. We've only got 4 cards here, yet it's asking us to enter a number between 1 and 5. So we'd expect the user to now choose a value between 1 and 4, not 1 and 5. Looking at this code here, this section here at least, it seems to me that there's a logic error, that the code has been written maybe with an expectation that the user enters a number between 1 and 5, and that because a card could be missing from the middle because that one's going to be removed, the card that they're playing, then it needs to compensate for that by the cards that come after it shuffling down another position, one more than they would do anyway. However, I think that the card has already been removed from the hand and everything's already shuffled down, so I think it maybe is trying to compensate for a problem that doesn't actually exist in this code here. It probably needs a bit more of a looking at, and I'm more than happy for you to come to me with your comments to tell me what you think the problem is and how easy it is to fix. If you're not a student that I teach and you're watching this video on YouTube, feel free to post your comments underneath the video on YouTube and tell me what you think and how we'd go about fixing it. Anyway, at this point then, it will check if they've discarded a key card. It's looking at the first character in the card description, which gets returned here. So this is the card they're trying to get rid of. It's looking at the first character in its description. Is it a K? That means it's a key, because remember, they should have entered a number of a card that is a key card. If it is, great stuff. It's going to remove that card from the player's hand, and then it's going to add that card to the discard pile, at which point it returns. So that is effectively the end of this function if the user chose a valid key card to get rid of. If, however, they didn't, so it could be that they entered a D to say I want to discard 5 cards instead, at which point it would have failed on the try pass, so it wouldn't have done any of this and it will continue from here. It could be they entered a number that was not in the range 1 to 5, in which case it's going to come down here Okay, it could be they entered a valid number, but it's not a key card, in which case it will come down here. So what's it doing down here? Well, it's just getting rid of 5 cards from the deck. It's iterating 5 times, and you notice there's a bit of checking here, so it's making sure that there are still cards in the deck left, because we can't keep on taking cards from the deck if it's empty. It iterates 5 times, takes a card from the deck, adds that card to the discard pile. Okay, so that's the other option if we aren't getting rid of one of our key cards. So having just completed current card.process here, let's have a look at this while loop that follows. Let's just scroll down a little bit. So this while loop that we've got here checks that the player has between 1 and 4 cards left in their hand. If so, it needs to deal more cards to make up the player's hand to 5 cards. So each time it does that, first thing it does is it checks if the card on the top of the deck is a difficulty card. If so, it places that card on the discard pile. If it's not a difficulty card, then it moves it from the deck to the player's hand here. Finally, it checks if the deck is empty and the player has fewer than 5 cards left in their hand here. If so, then it's game over. So we've looked at what happens when the player chooses option U to use a card, followed by D to discard that card. So if instead they chose to play the card, i.e. add the cards to the sequence, the code checks the condition here in the else if branch, and we've got play cards to sequence being called, passing card choice as a parameter. Remember, card choice is the integer, the number that represent that card in the hand that they wish to play. So the purpose of this method is to play the card to the sequence and see if it meets any of the challenges. So firstly, it checks that there's at least 1 card already in the card sequence. If so, it then checks the card description of the card that's being played. This is the one in the hand that they're playing, and checks it's not the same as that of the last card that was added to the sequence. And that is because the player cannot play a card from their hand to the lock sequence if that card represents the same type of tool as the card most recently added to the lock sequence. So you can't, for instance, play a file followed by another file. Just notice that we've got an if, but there's no else branch here for this if. So if the player tries to play a card that's the same as the last one in the sequence, you don't actually get an error message telling you that you're not able to do that. It just won't do it. So if they're not the same, so we're playing a card that's different to the last one in the sequence, then move card is called here. This time it's moving the card then from the player's hand to the sequence card collection. Let's just revisit move card. So when we looked at this earlier, we were looking at it in the context of dealing cards from the deck to the player's hand. This time we've got cards that are going from the hand collection to the sequence card collection. So we'll be going down the if branch of our if else statement this time. So this time we're going from hand to sequence. So the card is removed from the from collection, which is the hand. If it's not null, i.e. there's an actual card to remove there, it adds the card to the to collection, which is the sequence as we look at the code now. The score gets retrieved for that card. This is just a simple get method which simply returns the value of the score, which is an attribute of the card. So that's then returned. So that gets put into score. It'll skip the else and return score. So the return value from this, which was the card score, is added to this score attribute here. Next, get card from deck is called, which will deal a new card to the player's hand and we looked at this earlier. If the sequence is empty, so there aren't already some cards in the sequence, remember we checked this here if there are cards in the sequence. If not, then it will go down the else branch and do these two lines here, which basically do the same thing, but it doesn't need to check if the card being added to the sequence is the same as the previous card in the sequence. And now it's going to call check if lock challenge met. So the purpose of this method is to see if after the player's played a card to the sequence, if it matches one of the challenges on the current lock. So you can see we've got this for loop here. So this is iterating using this for loop, and it's iterating backwards. You can see it's got this value of count going down here. It's iterating backwards from the last card in the sequence to the highest of either 0, which would be the first card, or 3 cards from the end. So you can see here it's the highest, so using math.max, the highest of either 0 or 3 cards from the end. It uses this sequence as string variable to build up a string consisting of the descriptions of the cards in the sequence. Each time it prepends, i.e. adds to the start, the description of the card to the sequence strings and puts a comma between each one. Okay, so you can see sequence as string, it takes the current sequence as string, which starts off as an empty string, and it puts a comma in front of it, and then we've got sequence as string as was. As it iterates, it calls check if condition met. So it gets a description, puts that again at the start. It calls this check if condition met on the current lock, and it passes that sequence as string as a parameter to compare the two. And if this returns true, then the method itself, this check if lock challenge met, would also return true. This is a method we're talking about, check if condition met. It's in the lock class. So it's been passed this sequence, which is the string which defines the last cards in the sequence pile. The subroutine, as we can see, uses a for each, so it iterates through each of the challenges in the current lock. It calls get met on each of those challenges, which is returning a true or false value, which is stored in the met attribute. So it's actually checking if it's false. Okay, so if the challenge hasn't been met. So it also checks if the sequence is the same as the result of a call to convert condition to string, which when it's past the get condition, when it's past the condition attribute, which itself is a list of strings. So that's the condition attribute of the current challenge. We need to see how convert condition to string, when past a condition, returns a string that can be compared to the sequence. So we can see that this is actually quite similar to the code that we've just looked at. It takes a list of strings here, and what it's doing is it's just going around this loop here, and it's formatting them as a single string. And again, you can see it's separating each of the conditions with commas, and then once it's formatted that, then it returns that string. So what we're looking at with this if statement, when we're comparing these two things, we're comparing the string that we created earlier from the cards that are in the sequence pile to the string that we've just created from the conditions in the current challenge of the current lock. So if they are the same, then we've met that challenge. So for that particular challenge, it calls set met, and it passes the value true. So met will get set to true. Otherwise, it will keep on iterating through the other challenges, so it'll go through the rest of them. Now, if a challenge has already been met, then it will ignore it because it's using if not get met. So if it hasn't already been met, then it ignores it. It doesn't look at it again. If it drops out of the for loop without returning true, so it didn't meet the challenges, hasn't met any challenges, hasn't returned, so it will return false instead. So no challenge has been met and it returns false. So we've just called check if condition met here, and if it returns true, then this method, the one we're looking at, check if lock challenge met, will also return true. Otherwise, we're still going round this for loop. So it keeps iterating through the sequence collection. Remember, it's iterating backwards through that list of cards until it's looked at a combination of the last 3 cards, which is the maximum number of cards you get in a sequence. And then if no challenge has been met, it will eventually return false. So having played a card, and now we've checked if a challenge has been met, well, if it has met one of the challenges by playing that card, it outputs a message to say that you've met a challenge on that lock, and it adds 5 to your score. And that's now the end of this method, the play card to sequence. So what we've done is we've now looked at what happens when the player chooses either option from the menu, whether that's to discard or to play. So let's scroll down and we'll see what happens next in this play game method. So we can see there's an if statement that checks if the current lock has been solved. So this is get lock solved, and you can see it's iterating through each of the challenges in the lock. And for each challenge, it says if it returns false when it calls get met, if it's false, then it will return false, meaning the lock itself hasn't been solved yet. However, if it loops through all of these return true, it will drop out of this for each loop and return true to indicate that the lock itself has been solved. So if this returns true, then lock solved, this will get set to true also, and process lock solved will get called. Here it is, this is in the breakthrough class. So firstly, looking at the top, it adds 10 to your score and outputs a message to say that you've solved the lock, and tells you what your score is. And then we've got this while loop. So what is it doing? It's iterating while the number of cards on the discard pile is greater than 0. Each time it goes around the loop, it moves a card from the top of the discard pile, so that's at position 0, and it moves it back to the deck until the discard pile is empty. So basically all the cards from the discard pile get moved back to the deck, and then it needs to shuffle the deck. We looked at this method earlier, and it gets a new lock. So every time you've finished one of the locks, all the cards that were discarded earlier get moved back to the deck gets shuffled, and you get a new lock to solve. So process lock solved was called if the current lock had been solved after we played a card. It's now reached the bottom of the while loop. This is the while statement is a fair way up in the code. That's iterating while the lock is not solved and it's not game over yet. So it's going to repeat this process that we've just covered, continually asking the player to play a card and deal with it accordingly. Once the lock has been solved or it's game over, such as, you know, if there's no cards left on the deck, then it will call check if player has lost. So we've got that here, which we can see is returning a Boolean value that will be stored in that game over variable. So this is it, and this simply checks if there are any cards left in the deck. If there are no cards left in the deck, then it's game over, it will return true, otherwise it returns false. And we've now reached the bottom of the other big while loop. So this is where the program was checking if game over had been set to true or false. Okay, so it keeps going round if it's false. Remember, at this point it might be game over, or it might just be that they've solved a lock. So it depends on the return value from the last function call. If it was false, that big loop is going to iterate again. When we reach this point, we'd most likely drop out of the loop when we've used all the cards from the deck. If it's game over, finally we have this else down at the bottom here, so else. This was if there were no locks in the file. This is from the if statement at the start of the play game subroutine, which was checking if we had any locks. If we didn't manage to load any locks from the file, this bit of code here would stop us from being able to play the game. It's just a little bit of error checking there. So just rounding things off now, when the play game subroutine has finished, we drop back to the main method, back where we started. There's a final read line at the end, and that's just there to stop the console window from closing before we press enter, depending on what version of .NET you're using. So that's it for Breakthrough. Remember, I've just run briefly through how the main methods are called when you run the program. I haven't necessarily looked at every single branch of the code. That said, I do hope that you find it useful as part of your preparation for the exam. Goodbye.